Good morning. I see a new student today, Raghve Brahmakanti. Good morning. So, where were we yesterday? We have talked about reaction mechanism that during a organic reaction, a substrate comes to attack. A substrate comes to attack. Okay, so yesterday file is not there with us. So we'll be doing without that. A substrate comes to attack. Substrate, which is the reactant, gets attacked by attacking species. Attacking species, I told you yesterday, could be a electrophile, nucleophile, or free radical. Good morning, Sarojini. And then when the old bonds of the substrate break, they can break in homolytic way or a heterolytic way. You get to a reaction intermediate, which was carbocation, carbanion, and carbon free radical mostly. And finally, some newer bonds will form from reaction intermediate to give you the final product. During this reaction, whenever we go for any single step, every step will have its own transition state. We'll write as TS, and this type of symbol you will give to it. TS is a transition state which is actually an imaginary state which actually does not exist in nature, but we imagine it according to collision theory. Okay, so transition state 1 can be there, transition state 2 can be there. So number of transition states are always equal to number of steps in the reaction. Okay, remember this point as well. As a note point, you can mention number of transition state, TS I am writing, are equal to number of steps in which reaction proceed. Okay. So if a reaction is a complex reaction, means it has, let's say, 3 steps. So 3 transition states will be there. If a reaction is a simple reaction which has a 1 step, it will have only a single transition state, like you will study in the SN1, SN2. In unimolecular nucleophilic substitution SN1, reaction will be a 2-step reaction. So 2 transition states are going to be there. SN2 on the other hand, do not confuse the 2 with 2 steps. SN2, 2 means bimolecular reaction. Step is only 1. So SN2 has 1 step, 1 transition state. SN1 has 2 steps, 2 transition states. Okay. So this is what we have studied yesterday. Today, let us talk about the next topic of reaction mechanism. Very, very important one. Electron migration effects. Electron migration effect. Okay. Everything under an organic reaction, where the reaction will proceed to, which bond is going to break, which intermediate will form, everything depends on this particular topic, electron migration effect. The name itself tells you. Its other name is electron displacement effects. Displacement or migration means movement. So in which directions the sigma electrons and the pi electrons move? In which direction does a sigma electron or a pi electron move will be studied under electron migration effects. So there are 3 ways electrons can move, beta. In organic compound, there are 3 ways electrons can move. One is inductive effect. All of you would have studied about inductive effect, which refers to partial shifting of or partial displacement of electron, not complete shifting of electron. Every other effect will have a complete transfer of electron from one place to another place, whereas inductive effect is just a polarization. Polarization means partial shifting. So electrons will not lose their position and go somewhere else, but at their position only they'll just shift towards one of the atom. Like in HCl, you have seen in HCl, in hydrogen chloride, H is partial positive, Cl is partial negative. So electrons are little bit shifted towards the chlorine because of higher electronegativity of the chlorine. This is inductive effect. That the equally shared electron have moved towards the chlorine. This movement is called as inductive effect. Induction. Induction means movement of any particle in the influence of a more electronegative atom. So movement of electrons in the influence of more electronegative atom is called as inductive effect. This is the first one. It is not a very strong effect. It is one of the weakest one. Yes, Neelam, good morning. It is one of the weaker one. Siva Karthik, very good morning, beta. Sarojini also, good morning. So this is a very, very poor or weak effect. It's a very weak effect. Then second effect is called as hyperconjugation effect. Hyperconjugation effect. It is stronger than inductive effect. We call it as H effect. It has different names also. It is also called as a no bond resonance. Okay, its other name is no bond resonance. I'm writing it here itself. You can call it no bond resonance. It is also called as Baker-Nathan effect. Baker-Nathan effect by the name of scientists who have given it, but I'm not writing that here. You can just remember it as no bond resonance. It is also called as sigma pi resonance, but these are all less commonly used names. Most commonly used name is no bond resonance or hyperconjugation effect. It is stronger than inductive effect in terms of its ability to, affect a reaction. Its ability to affect a reaction, hyperconjugation, is more important effect than inductive effect. So whenever you are checking stability of carbocation, stability of carbon ion, or acidic character of an acid, or a basic character of a base, then hyperconjugation is a stronger effect than inductive. Okay, you have to first listen to hyperconjugation to decide any order. Then even a stronger effect than hyperconjugation is mesomeric effect. Mesomeric effect. In some other books, you can find it as resonance effect as well. Both mean the same thing. There is a small difference. When I'm explaining it, I'll tell you. Resonance is not an effect. Resonance is a phenomena. Whenever resonance occurs, due to this, electron migration is called as mesomeric effect. So name of effect is mesomeric, but the phenomena, the movement of alternate pi electrons, that movement itself is called as resonance. So resonance is not an effect. Resonance is a phenomena. It's a process. When that process occurs, whenever electrons move away, we say plus mesomeric effect, like that. So plus M minus M, the effect is mesomeric effect. I'm writing it as M. Some books may write it as R also. So for you, it is same as resonance. So resonance effect or mesomeric effect both mean the same thing. So resonance effect or mesomeric effect are both same. Resonance effect, R. Both mean the same thing. I'll write as M because that is more precise word to it. And the last one comes, which is completely different from all three. Completely different from these three. Which is going to be electromeric effect. Okay. Electromeric effect. Electromeric effect. This is itself a separate topic. You don't have to worry about electromeric effect. You don't have to check it anywhere. Why am I saying this? Because the very first three that we have written here, these are beta permanent effect. So whenever a molecule is given to you, any organic molecule is given to you, then inductive effect, hyperconjugation and mesomeric effect will always be present. These type of electron migrations are permanent. Permanent means if I take something like a phenol and I keep it inside a container. So in phenol, inductive effect will be working all the time. resonance or mesomeric effect will be working all the time. But electromeric effect is a temporary effect. That means it only works when attacking species approaches. So in a normal reactant substrate, in a substrate, there is no electromeric effect happening. So whenever a question comes from stability of carbocation, carbanion, alcohols, acidity, or basicity of amines, in all these questions you never have to check electromeric effect, because that will not be happening only. It will not be working. It works only when someone comes to attack on the substrate. So this is a temporary effect. It is a temporary effect. Means it can happen when someone come to attack, but it is not always in operation. So something which can happen, we'll call it ability, right or not? So temporary effect is also called as polarizability effect. Means there is ability to get polarized, but in the presence of a attacking species. Whereas permanent effects are called as polarization effect. That means due to first three effects, polarization is always there in the picture. But in the case of electromeric effect, polarization is possible, but it will take place when someone comes to attack. So permanent are also known as polarization effect. So first three are known as polarization effect. Last one is polarizability effect. Polarization effect. And last one is called as polarizability effect. Polarizability effect. Okay, so these are few of the things that can be asked directly to you. Which of the following is permanent, which is polarization, which is polarizability effect. Now, let us study them one by one. In short form, first you can easily remember that inductive effect just means movement of sigma electrons. Only sigma electrons will move. So in this, sigma electrons will move. You can write it as a short trick. In resonance effect, sigma will never move. Okay, sigma will never move or shift. Here pi electrons will move, that too in conjugation. Conjugation means alternate presence of pi. So whenever you have pi nothing pi, then pi electrons will move. So pi moves with pi. Pi moves with alternate pi. Pi moves with alternate pi. Instead of pi, sometimes lone pair will also come, sometimes positive charge might also be present. So in resonance, pi moves with pi. Whereas in hyperconjugation beta, it's a mix of inductive resonance, which means sigma moves with pi. Okay, it's a special type of resonance where sigma electrons also show conjugation with pi bond. So in hyperconjugation, sigma moves with pi. Okay, hyperconjugation, sigma travels with pi. Okay, this is the one. And in electromeric effect, what happens? First, I will teach you electromeric only because it's a simple one. In electromeric effect, pi electrons will move, but not in conjugation with pi. So, isolated pi electron will move. Isolated pi bond moves in presence of attacking species. In presence of attacking species. During any addition reaction, or during any reaction you can write, mostly it will be addition reaction. So when you will study addition reactions, in addition reactions, whenever an electrophile comes to attack or whenever a nucleophile comes to attack, then there will be a pi bond who will shift from between two atoms to one of the atom. Okay, electromeric effect first I'll show you, then rest of the three we'll study. Okay. So starting with electromeric effect, all of you can write it down. Electromeric effect. Electromeric effect. E effect. It refers to complete shifting of a pair of pi electrons. So whenever there is a double bond between two atoms or triple bond between two atoms, then that pi bond or pi electrons are going to completely shift to one of the atom in the presence of an attacking species. So it refers to complete shifting of a pair of pi electrons towards one of the atom in influence of attacking species. In influence of attacking species. Okay. So there are two types of electromeric effect which are possible, plus E and minus E. This all refers to which direction the electrons want to move. Let's say there is a double bond between you and me. I am A, you are B. There is a double bond between you and me. And a C comes to attack. C is the attacking species. Now let's say C attacks on me, I am A. C attacks on A and electrons also come to A. That is plus E effect. Okay. That is plus electromeric effect when the movement of electrons are in that direction in which attacker is coming to attack. So if attacker also attaches to A, electrons also move towards A, that is plus E. Okay. Plus E means same direction. Wherever attacking species comes, there only attacker comes. There only the pi electrons move. Then what is minus E? Opposite. Let's say attacker is coming on me. Attacker attacks on A, but electron move towards you. Electron move towards you. That becomes minus E effect. So whenever pi electrons and attacking species attach to same atom, it is plus E. Whenever they go to opposite atoms, that is minus E. So electromeric effect is of two types, plus E effect and minus E effect. Okay, it's very easy to learn. I'll just give you a trick to remember it also. Plus E effect and minus E effect. So plus E effect, I just told you, when pi electrons and attacking species both move towards same atom. Pi electron and attacking species both move towards same atom. See, when will this happen, beta? This is only going to happen when the attacking species is electron deficient. If the attacking species is electron deficient, let's say towards me a electron lover is coming, electrophile, which is electron deficient. If an electron lover is coming, then automatically electrons will be attracted towards him and they will go to the same place. So if the attacking species is electron deficient, then electrons automatically will come and be stable with it. Okay. So if there is an electrophile coming, electrophile like H plus, electrophile is a positive charge. So if a H plus is coming to attack here, automatically these electrons will come towards the H plus, so that plus minus can have good force of attraction. So what is plus E effect? Where will you see plus E effect? In electrophilic addition reaction. Which reaction? Electrophilic addition. In which reaction? Electrophilic addition. So you can write the example. In electrophilic addition reactions of alkenes. Electrophilic addition reaction of alkenes. Like when you take a alkene and try to add HBr on it, HCl on it, HI on it. So addition of hydrogen halide on alkene when you do, you will automatically see plus E effect will take place. For example, if I take the alkene to be propene, this is propene. Okay. Now I am reacting propene with HBr. All of you know about Markovnikov rule. We know that product is finally going to be 2-bromopropane, where the positive part of the addendum attaches to carbon with more hydrogen. So you know H plus will attach to this CH2 group and Br minus will go to the middle. Final product is going to be 2-bromopropane. But how did this happen? You see here the mechanism. The first step of mechanism is attack of electrophile, which represents your electromeric effect. So see beta, when though there was no attacking species nearby, then these pi electrons were localized. They were not moving anywhere. They were not going to this carbon. They were not going to this carbon. They were localized pi electrons. But as soon as HBr leaves its H plus is positively charged, so electron will start moving. So what will happen? See here, these electrons, if they move to left side, then a positive charge will be created on a primary carbon. We know that carbocations which are primary are not very good carbocation. Last class we have studied. But if these two electrons shift to the corner carbon, then what will happen? Then positive charge will be formed on the central carbon. It will make a secondary carbocation, a good carbocation. So this is what will happen. H plus goes towards the alkene, says I want to attach to you. Alkene says I have sent my electrons to the corner carbon and you are electron lover. You are electron lover. So you also go to the corner carbon. So electrons also went to corner carbon. And this incoming electrophile H plus, that also went to corner carbon only. That will also go and attach here only. That will also go and attach here only. So wherever the pi electrons have moved, there only the attacking species has attacked. There only the attacking species has attacked. So if I show your pi electrons with green color, let's say these were the pi electrons, they have finally gone to the corner carbon and the attacker has also gone to the corner carbon. Yes beta, everything will be taught in class. I'll tell everything again in the campus. This topic in the campus will come almost like after 2 months. Okay, here what we are dealing with, these are some important topics. If you have joined late, Telugu Tech, go to the live section of this channel. On this live section of the channel, you will find day 1, day 2, day 3, day 4, up to day 11 or 12, whichever it is going on today. All physics and chemistry classes will be there. So in case you have not studied before, you have time. 4 or 5 hours total you will take to complete. Okay. So this is plus E effect. Okay, so easy to remember. Plus E, easy to remember. How plus E? Easy to remember. It is plus E can also be thought of as E plus, electrophile. So plus E, E plus, both are same. Whenever electrophile comes, plus E happens. Whenever any electrophile will come to attack, always plus E will happen. Okay, so plus E effect example is electrophilic addition. And electrophilic addition will only occur to alkene, alkynes, and sometimes in benzene as well. Okay, so this is plus E effect. And finally, Br minus will attach here. That is not a concern, but second step will be this. But that is not something related to electromeric effect. So I am not writing that. Only first step has electromeric effect. When the pi electrons have moved. Only when the pi electrons have moved, that is called as electromeric effect. Its second step is not our concern for right now, which is attack of nucleophile. Okay. Minus E. Minus goes with minus. Minus E means nucleophilic addition, because nucleophiles have negative charge. Nucleophiles have negative charge. Whenever nucleophiles will come to add somewhere, then minus E effect will occur. So when pi electrons and attacking species or attacking reagent Here beta attacking reagent must be a nucleophile. You can think yourself now. Okay, must be a nucleophile. So if an electron rich person is coming to attack on me, automatically my pi electrons will feel repulsion. They will jump away from me. So this is opposite direction. So when pi electrons and attacking reagent move towards opposite atoms, So if attacking species comes to A, pi electrons will not go to A, pi electrons will go to B. When will this happen? This will happen in nucleophilic addition reaction. Where will you see nucleophilic addition reactions? Yesterday I told you in the chapter aldehyde ketones and nitriles, means cyanides. So example we can mention in nucleophilic addition reactions of aldehydes, ketones, cyanides, etc. Many more functional groups can be there, but these are the main ones in your syllabus. So when you go to the chapter aldehyde ketones, you will study a reaction of aldehyde ketones with something like Grignard reagent. So let's see how Grignard reagent reacts with this. For example, if I take any aldehyde, let me take the simple one, acetaldehyde or ethanol. In ethanol, carbon and oxygen are having a pi bond. See, when the pi bonds were between carbon and carbon, then though there was no polarization because the two carbons have same electronegativity. So pi electrons are neither attracted towards this carbon nor towards this carbon. But now here CO, this bond is a polar bond where carbon will be partial positive, oxygen will be partial negative because oxygen is more electronegative. So already carbon is feeling some electron deficiency. Carbon wants some electron rich person should come and attack on me. Now we have taken Grignard reagent. Grignard reagent is RMgX. Okay, RMgX, where the alkyl part is actually a carb anion, it is electron rich, and MgX part is electron deficient. So what will happen? Carbon says, I want some electron rich person to attack on me and give me some electrons. So this CH3 minus comes and attacks on the carbon. Now obviously you know carbon cannot make 5 bonds. Already carbon had 4 bonds. Carbon already had 1, 2, 3, 4 bonds. If this CH3 attacks here, carbon cannot make 5 bonds. So one bond of carbon it has to let go. Automatically these electrons and these green electrons, they will repel each other and the green electrons will jump onto the oxygen like this. This is what? This is minus E effect. Okay, this is what? This is minus E. In the previous one, electron jumped on CH2, proton also went to CH2. Both went to same atom, plus E. Here what has happened? Electrons have jumped to oxygen, but attacker has come to carbon. This is minus E effect. So when will you see minus E effect? Whenever a negative person will come to attack, nucleophile. Plus E when positive person comes to attack. So with the minus E effect, our final intermediate is going to look like this, CH3CH. This became O negative, and here the attacking species has come to attack, which I have shown with the yellow color. So let me write the nucleophile with yellow color, and the green electrons have gone to oxygen here, like this. And then finally, your alcohol will form after hydrolysis. That is not something, the reaction I am not telling, just the effect I am telling you. Okay, so this is minus E, this is plus E. One point as a note point you can mention, whenever inductive effect competes with electromeric effect, then winner is electromeric effect. This is something written in the NCERT, very nicely written. Okay, they have not explained it, but I'll tell you why it is. but as a line it is written in the NCERT that electromeric effect is more dominant over inductive effect when both are in opposite direction. Means inductive effect says electron should go here. Electromeric effect says electron should go here. Electron will go according to electromeric, not according to inductive. Okay. One example I'll show you in some time. So write down, when inductive effect and electromeric effect, when they are in same direction, obviously you don't have to worry about. Both are saying electron should go from left to right, you send the electrons from left to right, there's no problem. But when they are trying to send the electrons in opposite direction, then you always listen to mesomeric, electromeric effect. Hi Vijay Kumar, hello. So when inductive effect and electromeric effect operate in opposite directions, then electromeric effect is more dominant. This is a NCERT line. So you can put NCERT next to it. And what do they mean to say by this explanation is that by this line they mean to say that, let's say, let me take one example here. I have a ketone which is a alpha hydroxy ketone. Okay, or let me take a very, very highly pulling inductive effect group, NO2. So alpha nitro ketone I have taken. So this is acetone on which on the first carbon I have put a NO2 group. Okay, NO2 group is a highly electron withdrawing group. All of you would have studied. It's the best minus I group. So NO2 is saying that I want to pull the electron towards myself. I want to pull the electron towards myself by minus I. So according to NO2, these pi electrons should come to this carbon because they are getting pulled by NO2 this side. So according to NO2, electrons must come here. Correct. But still what was seen, whenever any nucleophile comes to attack, electrons never move towards this side. Electrons go towards oxygen only. That means electromeric effect, which says that I will send the electron upward, is more dominant, whereas the minus I of NO2 has no role to play in it. Okay, it has no role to play in it. So the pi electrons always move according to electromeric effect, but they ignore the inductive effect. So this is what they are trying to say here. So although there is a minus I, still electrons will move according to plus minus E effect. This is minus E effect. They are not moving according to minus I effect. Okay, so this is the one. This is all about electromeric effect. Only simple questions can be asked. They can show you a reaction and they can ask you which of the following is plus E, which of the following is minus E. Okay. Now we'll move on to the second effect, which is going to be the permanent effect, inductive effect. Inductive effect or I effect. All the effects that we have written, all four are of two types, plus and minus. Like we have studied plus E minus E, same way there is plus I minus I, same way there is plus M minus M and plus H minus H. Okay. Coming to the inductive effect. What is inductive effect? Inductive effect is just like tug of war. All of you have seen tug of war when there are some people attached there, some people attached here, and they are trying to pull a rope. Okay, they are trying to pull a rope. So let's say I am more stronger than the persons there. Let's say one of me is this side. This is me trying to pull from here. And here some small kids are there. Let's say 2-3 kids are there. Okay. And I'm trying to pull this rope. So when I pull this rope, what will happen? Rope will start coming towards me because I'm more stronger. And all these people will feel that they are giving the rope to me. Okay. So they will become the rope donors. I will become the rope withdrawer or puller. This push and pull is called as inductive effect. This push and pull is called as inductive effect. Whenever I will pull, in other terms, you are pushing. You are pushing. Who will feel the maximum force? The first person, obviously. You have seen that whenever you play tug of war, if you have played before, the last person, they are standing very happily. They don't even feel any pull. Okay. Whereas the first 2-3 people start falling down only. Okay. Maximum the first 2-3 people, they start falling down only. They feel a lot of force. So in the same way, in the inductive effect is distance dependent effect. The one who is attached nearest to the puller, he will feel maximum electron deficiency because electrons are moving here. So this will feel a lot of positive charge. Too much electron deficiency. Next person feel very less, little positive. Okay, this partial means little positive. Next person little positive. Next person very little positive. And after that, fourth person do not feel any pull only. He is relaxed and calm. He is not feeling anything. So that is how inductive effect works. So what is inductive effect? It is partial shifting, not complete. Partial shifting of sigma electrons. Partial shifting of sigma bond electrons towards the more electronegative atom. Partial shifting of sigma electrons towards the more electronegative atom. Who is going to be more electronegative atom in the organic chemistry? In the organic chemistry, almost everyone is more electronegative than carbon, like nitrogen containing compounds. Nitrogen is more electronegative than carbon. Oxygen is more electronegative. Halogens are more electronegative. Okay. So every time from carbon, 90% of the people will be pulling electrons towards themselves. Okay. That is inductive effect. So we'll write down. Inductive effect refers to partial shifting. Partial shifting is also called as polarization of sigma bond electrons. It refers to partial shifting of sigma bond electrons towards more electronegative atom / functional group. More electronegative atom / group. Partial shifting. Okay. It's not like a sigma bond will completely break only. Nothing will happen. Electrons will not just go from one place to another. They'll not jump. They'll partially shift. So when tug of war happens, it's not like the rope cuts and goes somewhere. Rope remains in the hands of everyone, but it just shifts from little bit from this side to that side. Okay. It is a permanent effect because this does not require any, attacking species to attack. For example, let me take the example of 1-chlorobutane. Okay. Apart from alkanes, everywhere inductive effect is there. Alkanes do not have inductive effect because everything is carbon. Then where is the difference in electronegativity? Okay. So in alkanes, you will not see any inductive effect. But in any other functional group, alkenes, alkynes, in the case of haloalkanes, in the case of alcohols, phenols, you will see inductive effect always will be present. So if I take 1-chlorobutane, this is how 1-chlorobutane looks like, CH3. CH2, 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 Cl. So wherever it's carbon, 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 there is no push and pull because carbons are of electron negativity same only. Hydrogen to carbon also you can neglect it because carbon and hydrogen also have very similar electronegativity. So there is no much push and pull between C and H as well. Push-pull only starts when any functional group comes and attaches, or when any alkene comes and attaches, or alkyne comes and attaches. Hello, Darwakar, Shri, what's up? Okay, so here, because of chlorine, chlorine says I am more electronegative than carbon. Chlorine starts pulling the electrons. So these sigma electrons shift towards chlorine somewhere here, like this. So chlorine becomes electron-rich person. This carbon becomes electron-poor person. Chlorine become partial negative. Yes, DNP will work, Kareem, correct. Partial negative, and carbon will become partial positive. And obviously, when this carbon, when the chlorine is having effect on the first carbon, some effect will be transferred to second carbon also, but little positive. Carbon number 1 gets the most effect. Carbon number 2 gets less effect. Carbon number 3 gets least effect, almost like 1%. So 90% goes here only almost. 8 to 9% goes to next one. Only 1% goes to the last one, to less than 1%. And then it diminishes. So inductive effect works up to third carbon of the chain. Up to third atom it works. After that it stops working. Okay. Then inductive effect has direction also. Inductive effect has direction also. So whenever you see a bond, always show the direction. Always show the direction from donor to puller. From donor side to puller side, show an arrow like this. On the bond only show the arrow. So electrons are moving from carbon chain. So carbon chain become the donor. Carbon chain become the donor, and chlorine becomes the puller. So this is how the inductive effect is moving. Here also a little bit moving, here also a little bit moving. So the one which donates will be called as EDG, electron donating group. So here this carbon chain, the alkyl chain, is acting like an electron donating group. This is acting like an electron donating group. I am writing it as EDG. This is called as plus I group. Electron donating group. Mostly electron donating groups are alkyl chains only. There are some functional group which can act as electron donating, like O negative, like NH negative. So whenever any functional group has a negative charge, then only it can donate. Otherwise, all are pullers only. Okay, so Cl is acting like a withdrawer, EWG, electron withdrawing group. EWG or minus I, electron withdrawing group. Okay, so never study it in such a way that one person is always plus I, one person is always minus I. It is not so. Push and pull depends on strength beta. If I am playing with you, maybe I am the puller, then you are the pusher, because I'll pull the rope from you. But what if I am playing with someone who is a WWE superstar, maybe like John Cena? Then obviously I am much weaker than him, so he will pull away. Then I'll become pusher, he will become puller. So plus I minus I is always relative. It's not that one person is always going to act like a plus I, not like that. In the same way, if this same carbon chain was attached to a O negative, let's say, or CO negative, same chain was attached to something like O negative. O negative says, I already have a minus charge. I don't want to pull. I already am electron rich. So I will push my electrons towards you. So now oxygen starts giving electron. This carbon will receive maximum electron. then this carbon will receive little electrons. This carbon will receive very little electrons. And oxygen will become partial positive. So oxygen, which already had a lot of negative charge, is trying to get rid of its charge by pushing its charge away. So now this is acting like an electron withdrawing group. Now the same carbon chain, which was EDG before, now it is EWG, electron withdrawing group. Now it is acting like a minus I, because the person next to it is a more strong pusher. Because this is electron donating group, plus I. So beta, whenever you see any molecule, always draw the inductive effect direction, then think who is plus I, minus I. Then think who is plus I and who is minus I. Very important. Okay. For example, let me look at phenyl group now, means benzene ring. But if I take benzene ring, and I take a alkyl group here, and if I take a benzene ring and I take a nitro group here, in this case beta, benzene ring carbon is sp2 carbon and alkyl carbon is sp3 carbon. We know that sp2 carbon is more electronegative. A sp2 carbon is more electronegative than a sp3 carbon. Then sp2 carbon will pull the electron towards itself. So this person is puller and this person is donor. So here this is EWG, electron withdrawing group, minus I. So the alkyl chain becomes electron donating group, plus I. Correct. Whereas when I compare carbon versus nitrogen, nitrogen is so much more electronegative than carbon. Nitrogen is much more electronegative than carbon. Then here nitrogen becomes the puller. So benzene has to become the donor. So here what will happen? NO2 will start pulling the electron towards itself. So this will become minus I, electron withdrawing group. Then benzene becomes plus I, electron donating group. I hope it is clear. So never ever try to mug up that this person is plus I, this is minus I, plus I, minus I. Don't mug up that. Carbons may act like a plus I. Mostly carbons act like a plus I. They can act as minus I also. Benzene may act as minus I. Benzene or phenyl, we'll call it. Phenyl may act as minus I. Phenyl may act as plus I. Is this point clear, Kareem? So now we are going to see which all groups show plus I and minus I in general. Okay. Before that, let us write down few important points about inductive effect. Important note about inductive effect. The very first one is it is permanent effect. Second, it is distance dependent effect. It is distance dependent effect. I already explained to you, and it decreases with distance. Wherever the inductive effect starts from, wherever the push and pull starts from, as you go away from there, it will decrease. So it decreases with the distance. So whenever distance will increase, effect will decrease. Okay. It only works till third directly attached atom. only observed up to third carbon atom in chain. Because we are talking about organic compound, we'll be only talking about carbon atoms. So when you have a long alkyl chain, only up to third carbon it is observed. For example, beta, you can see here. Let's say I have a NH2 group here attached to a cyclohexane. Cyclohexanamine I'm taking here. Or you can take something like CH3, C, CH3, H, CH2, Cl. And here let me take CH2, CH3. Let me take one more example. CH3, CH2, C double bond, CH2, 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 CH3. Okay, better. First of all, you have to think where the inductive effect is starting from. So here, this is the NH2 group. Nitrogen is more electronegative. It is -I. So here the inductive effect is starting. So it will work up to third carbon of the chain. So see here, everybody. This is carbon number 1. It will work here. This is carbon number 2. This is also carbon number 2 because both are same only, no. With respect to NH2, this is carbon number 2. And this is carbon number 3. And this is carbon number 4. It will not go up to 4. It will go up to 3 only. So this carbon will feel little bit positive. This will feel little positive. So it is decreasing with distance. Carbon 3 will feel little positive. Carbon 3 will feel little positive. Carbon 4 will not even, get affected. It will not observe any inductive effect. So actually electrons are only moving in this bond, and this bond. Then you don't have to show other arrows. So don't show arrows at the bottom carbon. Up to third carbon, it is working like this. Okay. Same way in the next one. Cl is the one who is the electron withdrawing group, -I. It starts from here, reaches to first carbon, reaches to second carbon, reaches to third carbon, but does not go to fourth carbon. So when you show the arrow here, 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 where the electrons are moving. Okay, beta. Next one. It will start from this ketone group, beta. Ketone is the functional group, which is -I group. So it will pull from both sides. So this is carbon number 1, partial positive. This is also carbon number 1, partial positive. Both sides it will pull from. Here also, here also. So ketone has a sp2 carbon. sp2 carbon is highly electronegative. It will start pulling from both sides. From this side, first, second, and third. This side there is no third carbon, so it will not pull. So the direction of inductive effect should be clear to you how to write. Okay, quickly write it down. I will give you some time to note. Then we are moving forward. You can write it down. I am giving you some time. Then we'll start with the other note points, which is going to be fourth one. It follows the order. It follows the priority order. D and P. D more important than N, more important than P. D means beta distance. D means distance. N means number of groups. P means power of the group. P means power of the group. Distance, number, power. What is the meaning of this? This will be clear when you do questions. It will be clear while doing applications. While doing applications. Okay. So let us look at the minus I groups now and look at the plus I groups, their order, and one application I will try to finish today. Other applications will be done in the later classes. So first let us see the examples of minus I or electron withdrawing groups. I just told you minus I plus I is not fixed. It is relative. So why do I say minus I? I am just trying to say when the groups are attached to alkyl chains. When the groups are attached to alkyl chains, let's say a group is attached here, G. When will this G be a minus I or plus I? That we can tell. So we'll write down what are these minus I electron withdrawing groups. The most strongest one is NF3 positive group. We'll remember it with a story. Story goes like this, that let's say there are two police cases. Okay. There are two police cases. One accident happened. First police case is about an accident. So there was a car and the car got derailed and some people died. Later, police started thinking that whose car was it? It was a high profile case. So people were thinking either Farhan Akhtar was driving the car, or Hrithik Roshan was driving the car, or Shah Rukh Khan was driving the car, or Salman was driving the car. But finally, as you know, by bribing the cops and everything, they have removed their name, and finally they came to know that the car belonged to another person by the name Sonu Chaudhary. Okay. Sonu Chaudhary. The car belongs to someone by the name Sonu Chaudhary. Neither Farhan, nor Hrithik, nor Shah Rukh. Sonu Chaudhary's car it was. So case closed. This case was handled by two people, and they are father and son only. So father is collector and the son is inspector. Collector, inspector, like that. Father collector and brother inspector. Okay. So this was the first case. Second case is alcohol came to the police station and said, I am looking for my mother. Please do a DNA test and tell me who is my mother. I don't know who my mother is. So we finally came to know that benzene is your mother. Who is the mother? Benzene is the mother of alcohol. So two cases are there. The hit and run case, Sonu Chaudhary's car it was. Good, Rashmi, good. Sonu Chaudhary's car it was in the hit and run case. And who is the mother of alcohol? It is benzene. In Hindi I will tell. Okay. Na Farhan, na Hrithik, Shah Rukh. Na Farhan, na Hrithik, Shah Rukh. Na Hrithik is NR3, sorry. Na Farhan means NF3 positive. Na Hrithik means NR3 positive. Shah Rukh means SR2 positive. Na Farhan, na Hrithik, Shah Rukh. Na hi naughty Salman. Na Farhan, na Hrithik, Shah Rukh. Na Farhan, na Hrithik, Shah Rukh. Na hi naughty Salman. Salman means sulfonic acid. Na Farhan, na Hrithik, Shah Rukh. Neither means na hi. Naughty Salman. Sonu Chaudhary की कार में. Sonu means CN, Chaudhary means CHO, car means carboxylic acid. None of them were there in the Sonu Chaudhary's car. Na hi naughty Salman, Sonu Chaudhary की कार में. Car means carboxylic acid. Sonu Chaudhary car में. Case is clear. Who were solving the case? Father collector, brother inspector. Father and the son, father brother we'll call it. These two were the police officers. So father collector, brother inspector. Father collector, brother inspector. Or second case was alcohol's mother alkyne nahi. Alkyne is not the mother. Benzene hai. So we'll say benzene hai. Mother alkyne nahi, benzene hai. Okay. So inspector. Or alcohol's mother alkyne nahi. Alkyne is not the mother, but benzene is the mother. So we'll say benz, call it as ene hai. Benzene hai. Okay, so this is the decreasing order beta. Most minus I, NF3, NR3, SR2, NH3 positive. So obviously anybody with a positive charge is going to be very electron deficient. They will pull the electron like anything. And that too 3,3 fluorines are attached to it. So that's a very, very, very strong puller. The strongest one, NF3 positive. NF3 positive, NR3 positive, SR2 positive, these are the ones. Then NO2 is very, very strong puller among all the neutral functional groups. So among the neutral functional groups, the BAP of all the pullers, the father of all the pullers is NO2. Then SO3, then CN, then CHO, then COH, then fluorine, chlorine, brother, inspector, or alcohol's mother, alkyne nahi, benzene hai. This is the order which is there for minus I. Is this clear to everybody? Please tell me quickly. Is this clear to everybody? Please tell me. Can you remember it? If you remember it, then many questions will become very easy for you while checking for stability of carbocation, carbanion, or even when you have to check the acidic strength of carboxylic acid. Okay, so this is the thing. This is the order of minus I. Then I will tell you the order of plus I. Just write it down. I will give you 5 minutes. Then I will tell you the order of plus I as well. What is that? Okay, then it comes to order of plus I. Then it comes to order of plus I. Electron donating groups. There are not many electron donating functional groups, just that O minus and CO minus you can remember. Apart from this, Only alkyl chains, which is tertiary alkyl group, which is tertiary butyl, then secondary alkyl group, which is isopropyl, then primary alkyl group, which is ethyl, and then just normal methyl. These are the only examples required for the plus I. Apart from this, beta, among CH3, CD3 and CT3, CT3 is more plus I than CD3, then CH3. And then comes your hydrogen, which has no effect, but tritium and deuterium still have little bit of inductive effect. So we have kept the reference to be hydrogen, which shows no effect here. So hydrogen, circle, you can write no effect. In the previous case also you can write hydrogen, circle, no effect. So this is the one. So all the other people have some kind of inductive effect except hydrogen. So when hydrogen is attached to any carbon, there is no effect you have to consider. When any other thing is attached to carbon, then you have to consider the inductive effect. So quickly revise what you have done today and write it down. We have talked about inductive effect and electromeric effect in today's class. Minus E plus E, minus E plus E, minus I plus I is what I have told you in this class. This was an electromeric effect all in one page. It's a small thing. Electromeric effect is not that difficult to study. Okay, so this is the electromeric effect. Then we have seen inductive effect, how to write the direction of inductive effect. After direction, we have seen some important points about inductive effect. It is permanent in nature. It is distance dependent. And then we have seen the order and we have learned the order. So this is all about today's class. We'll keep it till here. Okay. And please write down this order, everybody, those who have not written. So I'll see you all in the next class. Thank you. Bye-bye. Keep it on.